Put these covers on last night because there were a few flies running around. You don't want them on here. But now we have a cap, and we've had a veritable explosion of carbon dioxide, and the yeast has really started to ferment. So, all right. So what we're going to do is we're going to break the cap, okay? And we're going to see that this cap is very light, sort of husky, germ kind of material. And it's being actually floated up out of here. And that cap is 4 inches thick. And there's so much carbon dioxide coming up through this that it'll just take all the lighter material and keep it at the top. And what we're seeing is an anaerobic reaction that's taking place. There's so much carbon dioxide in here, there's no oxygen to speak of, and yeast have two metabolizing modes. One metabolizing mode is an oxygen mode, and in that they will tend to reproduce, and but they won't make as much alcohol, or they'll make alcohol of different character. What you want is to keep them in an anaerobic mode, and that they do that naturally. They'll do it, they'll take over a space, whatever space you give them, and they will start this metabolism process, and they will make alcohol, not reproduce quite so fast. But you really don't have to worry a lot about bacteria at this time, other than anaerobic bacteria. At the beginning, we were worried about aerobic bacteria contaminating the mash and getting a jump on the yeast, because the aerobic bacteria can multiply much faster. The yeast only multiply about every 40 minutes, and the bacteria multiply about every 20 minutes. Now, all those aerobic bacteria have been killed. There may well be some anaerobic bacteria still left in here that are doing their thing, but we hope that it's not too much. We're going to check the pH, we're going to check the sugar, and we're going to check the temperature. And this won't do this anymore, really. The explosion is over. We missed it. It happened sometime probably about, 6 hours after we set the batch. And it probably just frothed up and really came to life all in a rush. I've never actually been here to see it, because by the time we get finished cooking at the end of the day, I'm pretty tuckered out, and I don't have time to stand there. I spend enough time standing around watching this vat of stuff do things. We're going to find a temperature differential between the top and the bottom of this tank, just like we were seeing all day yesterday. Sometimes it's greater, sometimes it's less. When it gets down less, and like 4 degrees between top and bottom, we'll know the fermentation is over. The other way we're going to know the fermentation is over is that it's going to stop making carbon dioxide. And when that happens, you're going to go through a period where it's known as the cap is falling. And so the cap will get thinner. Right now it's nice and 4 inches thick. It'll go to a 2-inch cap, it'll go into a 1-inch cap, and then at the end of the run, you're going to see just clear liquid on the top, and it'll still be making some bubbles, but it won't be enough to justify continuing to ferment it. And also, those last bubbles are starting to be lactobacillus bacteria, which are then consuming the alcohol. You're fighting sort of a race against them, and you can be confused at the end of the run because, it's still bubbling, and it'll bubble for days. But what it's doing is it's starting to turn to vinegar, because lactobacillus malt is particularly loaded with lactobacillus, but we use enzymes, so it's a little different. But they get in here anyway. They're on the corn, they're everywhere. And so they will sour milk in your home, and they will sour mash here. And so you have to choose carefully when the end of the run is. But I've got a system that I'll show you later, which is pretty foolproof. It's something that beer makers use. Remember last night we were wondering whether it was about 4.9 or 4.2 or 4 point whatever. All right, this thing has gone down so low that it's even off the scale. So we started out, we were guessing we were about 4.9, and now we're well down below 4.6, somewhere off the scale of what this pH meter will read. This is, 12, let's see, set at 4 o'clock, and it's now 10 o'clock, which is 14 hours. And this is what the beer looks like. It's still mostly sugar, but you can start to taste a little cider-like taste to it. There's no carbon dioxide in it to speak of, but when it continues to ferment and you taste it, it will get a Budweiser-like taste. There'll be so much carbon dioxide in it that it can't all get out. And just like beer, which they then bottle exactly like that, but ours will continue to just vent its carbon dioxide, and we'll end up with flat beer. Flat Budweiser beer is what we're going to use as our starting mixture. Although Budweiser would not like that comparison, and they don't use corn. If they do, they only use very small amounts of it. They use much more malt, and so does every other brewer. Although sometimes, like Budweiser, and in the 60s and 70s, what they were doing was they were using rice as an addition to extend their malt. And they put the hydrometer in here, and we're going to see that we are still at 20% sugar. So we used 5%, between 5 and 7% sugar overnight. And we know that because the specific gravity has changed. With sugar, with lots of sugar, it tends to drive the hydrometer out. So the more sugar you put into this water, the denser it's going to make it. And then what happens is, as the metabolic process continues, that sugar is broken down, and the specific gravity of the liquid changes, and it sinks farther and farther and farther down, and then at the end of the run, it's going to be way down here at 0. You're going to know that there's no more fermentable sugars. All right, we're going to double check that against the refractometer. By just taking a couple of drops and smearing it on the refractometer. And hopefully that's enough to get a reading. Yep. And the refractometer is reading 22. So it's consistent. Yesterday the refractometer was reading 27 at the highest, and this was reading 26 at the highest. Now this is reading 20, and this is reading 22. So the difference in sugar registration is about the same between the two instruments. Since we broke the cap in order to take our sample, the cap was actually keeping a lot of carbon dioxide trapped down in this mixture, and so by just even breaking it just that little bit in order to get my sample, all the carbon dioxide has bubbled up out of here, and it has become very active. And eventually the cap will form in about 15 or 20 minutes. All of that loose material will again float up to the top and be levitated on top of the little bit of carbon dioxide that's holding it up. And we may even see this cap get thicker tomorrow. And we'll be back tomorrow. So we'll just take, I don't want to rely on the temperature that I took off of that. There's 85, that's looking better. I'd like this thing to run between 88 degrees and 92 degrees. That's the best zone for the yeast to survive. You can set these yeast in the batch up to 105 degrees, and you can ferment with them up to about 95, 96 degrees, but boy, that's really getting hot. And as I mentioned before, the metabolic pathways become different. You make different types of alcohol. You see this stuff's just bubbling and roiling up through there. So we were up to 86.1, and I wish it was a little warmer than that. The other thing I could do is I could put a blanket on it. I could take those insulation things. If I was going to be here for the day, I might just put a blanket on it or a lid on it, and let the heat stay in it a little bit more. And that's all we have to do today. I will have to clean up, but other than watch the batch ferment and continue to monitor the temperature and watch for the cap to fall, there's nothing else to do. And as a matter of fact, there's so much carbon dioxide in here, you really can't get a lot of other work done unless you've got a way to open up the doors and the windows and really vent the place.